Okay, so I thought I was done troubleshooting router 1, trying to figure out why router 1 and router 2 are not talking to each other. Here's the thing. Um, this network, 129.168.12.0, that's a class, actually that's a class B. It's a very large class B. But that is very definitely not a network that I'm in. So, uh, whereas everything looked okay, be very, very careful. Check everything. Um, because I'll fix this next, and then move on to router 2 to figure out why. And here's the weird thing. Um, it doesn't quite make sense to me uh, why router 1, okay, why router 1 and router 2 are uh, adjacent with each other. That doesn't make sense unless router 1 and router 2 both have the same wrong kind of configuration. So I'll have to look for that. Because strictly speaking, if all the addressing is right on router 2, and this network statement is wrong on router 1, then the neighbor adjacency shouldn't exist in the first place. Okay. Yeah, there it is again, 129. So config T, router OSPF 1, no network. Now, it is important. I sort of covered this in a previous video about how to select the networks that you should use, you should include in your routing processes. The simplest way to do it is actually this way. Let me do this. So do show route connected. Do show IP route connected. Yes. There. So I see 192.168.10/24. I see 192.168.12.0/30. And I see 13.0/30. That's all right. But if I look at my show IP protocol statement, I see 10/24. I see 13/0/30, and I see 129.168.12.0/30, which frankly doesn't exist. It is not good enough for maximal correctness to just drop in the new network. Now, granted, a network which physically doesn't exist on the network or on the router will not be included in the routing process, whether you declare it or not. But it is best to take all the junk and the cruft out of the process. Leave nothing there that could confuse you. Remember, you may have to. You should build your documentation. You should um, store it, etc., so that it will be useful to you at a moment when you are tired and stressed and confused. Don't leave these things undocumented on the theory that, hey, when I have to deal with this again, I'll have all the time in the world. What if you have to solve this problem while you're sitting in an unair-conditioned room with a router or a switch that's just not working correctly? And it has to be fixed right now, and you have to sit there in a folding steel chair with a laptop on your lap and a console cable up to the device, trying to solve it in the most uncomfortable conditions you can imagine. I'm actually thinking of a physical place when I say this. At the Sweetwater campus, before the Bluebonnet building burned down, there was a network closet on the outside, essentially on the outside of that building, in a room by itself on the outside of that building, on the first floor. And the networking equipment was there. There was a switch. I can't remember whether there was a router, but there was a switch. There were some wireless access points, and all of the wired connectivity for those student dorm rooms went through that unair-conditioned, poorly lit space, which also had water heaters. And imagine if you will, because this is West Texas and it is not in an air-conditioned space. It is not a climate-controlled space. So cobwebs, spiders, dead crickets everywhere. Um, I thought of it as cricket hell. And it didn't smell all that good because you think about what a room carpeted with the carcasses of possibly thousands of dead crickets. Think about what that smells like. Think about those working conditions. Then think about having to solve a networking problem right now in those conditions. If you don't have your documentation ready, up to date, ready to go so you can look at the problem, look at the config, see the problem immediately, and fix it, that's not going to be comfortable. So do yourself a favor, document everything. So no network 129.168.12.0 0.0.0.3 area 0. Now what I can do, the easy part of this, is I can take that network statement and fix it like this. Because all that's the problem here is the 192 has been, those two digits have been reversed. From the 190, the 192 becomes the 129. The rest of it is okay. The mask is fine. Of course, we noticed earlier that these networks were configured incorrectly in interface mode. If I had left those as /24s, no, you wouldn't have gotten nothing. Everything has to match at layer 3 for neighbor adjacencies to form. So I'm going to do this, and let me see. Boom. Okay. Let's see. Okay, there. See, what it has now done is establish a neighbor adjacency with 23.1, which is a little weird, because 23.1, okay, 23, yes, 23.1 is actually router 2. Here's the question though. Where did that neighbor adjacency from 2.2 come from? We're going to have to figure that out too. See here. Okay, oh, okay, now I see the problem. Pay close attention to this. This is what's confusing me, but that's not actually an OSPF v2 thing. That is a OSPF v3 neighbor adjacency. And the fact that this neighbor adjacency has just formed tells me something else. Router 2 doesn't have an appropriate router ID for OSPF v2. So I need to fix that too. So let's do show IP route again. Okay, and 1 and 2 are now talking to each other. I see the 2.0 network. So the pings I was doing before, I can see, let's see if, and now, good. 2.3 goes through. Good. And that means conversely that the ping from, okay, so we've got partial connectivity now. Let me look right quick at router 2. So, but notice, let's see if router 3 can get to either, okay, no, 21.3, what was I thinking? 2.3. Okay, 2.3. Let's see, okay, this is, let's see 1.3. Okay, yeah, PC3 is still out of luck. This one down here. But it can ping its gateway, yes. Okay, so let's look at router 2 right quick. Show IP protocols. So its router ID is wrong. It is talking to, its information list, it's got information coming from itself and information coming from router 1. There is no neighbor adjacency between router 2 and router 3. There's also no neighbor adjacency between router 1 and router 3. So we know that something is seriously wrong on router 3, but we're not going to go solve that problem yet. We're going to look at router 2 to see if everything is right here. This first question is, are my masks right? Are my areas right? And the area question, we have an answer. everything in this area is in area 0, that's fine. The masks look to be right as well. I've got 192.168.20/24. I've got 192.168.12.0/13. Sorry, /3, and I've got 192.168.23.0/30. And that precisely matches my configuration. Let's do show IP route. Let's see. So I'm talking to 1 and 2. 1 and 2 are very clearly talking to each other. I can also do this with show IP OSPF neighbor. Now, no, because this is a packet tracer. This is, of course, is written as a live lab. So OSPF show IP OSPF neighbor show IP OSPF interface brief should work, but it is not implemented in this version of packet tracer. I'm still using packet tracer 722. I have not tried doing this same lab in packet tracer 730. If you are using 730 and fun things like show run interface and show IP OSPF interface brief work, great. If not, just understand there are still ways to learn everything you want to learn. So let's fix the router ID process. Now that is not, the router ID thing is not a deal breaker, but it is a good thing to fix. Actually, you know what? Before I do that, I'm going to do show run pipe begin router OSPF. Okay, so technically speaking, it would be a good idea to make gig00 a passive interface. So we're going to do that. Now, making gig00 a passive interface won't form any routing relationships that don't already exist. But what it will help you do is secure the network, which is always a good idea. So router OSPF 1 passive interface gig000, and then router ID 2.2.2.2, and then we have to end a clear IP OSPF process. Yes. Now, so the neighbor relationships are going down and they're coming back up. Notice that we are not actually clearing the v6 process at all. So I can now do this. Let's see, do show IP OSPF neighbor. Okay, I've got a neighbor relationship with 2.0, with 2.2. Show IP OSPF neighbor. And I've got 1.1, 2.2, 1.1. Notice, because I'm using a gigabit network, there's a DR election taking place. 2.2 is the DR. 2.2 is the DR. 1.1 is the DR other. Strangely enough, there's not a BDR election taking place across this segment. But now, I think things look good with router 2. So I'm going to stop here and move on to router 3. Now, this is going to be kind of a longish video series.